Hello grade 12s and welcome to question number 6 of the November 2021 Physical Science Paper 2 exam. This question deals with Le Chatelier's principle and chemical equilibrium. They say consider the balance equation below for the hypothetical reaction that takes place in a sealed 2 decimeter cubed container at 300 Kelvin. We have been given the volume of the container and we have been provided with temperature. The equation is 2p gas plus q2 gas is going to form 2 moles of pq gas. Question 6.1 says, define the term chemical equilibrium. We know that we can define chemical equilibrium as the stage in a chemical reaction where the rate of the forward reaction is equal to the rate of the reverse reaction. Alternatively, you can say that it is the stage in a chemical reaction when the concentrations of reactants and products remain constant. Either of these definitions is going to get you 2 marks. But a big mistake that I see learners make is that they say that the chemical equilibrium is where the concentrations of the reactants and products are equal instead of constant. Please be very careful of this mistake, avoid making it, and learn your definitions word for word off by heart. Question 6.2 says, the amount of each substance present in the equilibrium mixture at 300 Kelvin is shown below. We have 0.8 moles of P at equilibrium, 0.8 moles of Q2 at equilibrium, and 3.2 moles of PQ at equilibrium. The temperature of the container is now increased to 350 Kelvin. When a new equilibrium is established, it is found that 1.2 mole of P is present in the container. So what has happened is that the number of moles of P has increased from 0.8 to 1.2. If we go up to the chemical equation that was provided to us, we can see that this is a reversible reaction and that compound P is one of the reactants. So now, question 6.2.1 says, is the heat of the reaction positive or negative? We remember that a positive heat of reaction refers to an endothermic reaction, while negative refers to an exothermic reaction. So we would like to determine if the reaction is endothermic or exothermic. When the temperature is increased, we find that P, a reactant, increases, right? So we end up with more reactant. This is the reactant of the forward reaction at equilibrium. So what that means is when the temperature increases, the reverse reaction is favored. We know that a temperature increase will result in the endothermic reaction being favored according to Le Chatelier's principle. Therefore, we know that the reverse reaction is endothermic while the forward reaction is exothermic. We can therefore say that the answer to question 6.2.1 is negative. The forward reaction is negative. It is the exothermic reaction that is not favored, and this is for 1 mark. Question 6.2.2 now says, use Le Chatelier's principle to explain the answer. Firstly, we state that Le Chatelier's principle says that an increase in temperature will favor the endothermic reaction, right? We have increased the temperature and now we say what Le Chatelier's principle states. The reverse reaction is therefore favored. We know that the reverse reaction is favored because the concentration of reactants increases, or we can say the concentration of the products decreases. For any one of these statements, you're going to get your 2nd mark. So far we have 1 mark for stating that an increase in temperature favors an endothermic reaction, and then the 2nd mark is for stating that the reverse reaction is favored. So if the reverse reaction is favored, it means that the reverse reaction is the endothermic reaction. And in conclusion, we say that the forward reaction is therefore exothermic, and this will get us the last mark. This question is out of 3 marks, and that is why we give 3 valid points in answer to this question. Question number 6.2.3 says, calculate the equilibrium constant at 350 Kelvin. So this question is out of 8 marks, and of course, since we are dealing with equilibrium, we know that we're going to be making use of a Rice table. We have quite a few values that are known to us. We know that all of these are the initial number of moles of each of the reactants and the product, and that this is the number of moles of P at equilibrium. So we're going to place these values into the Rice table. Our Rice table will look like this. R is for the ratio, which is 2 to 1 to 2. Initial number of mole measured in mole, and we do state the correct SI unit, please. C is for the change in the number of mole measured in mole. The first E is for equilibrium number of mole, of course, measured in mole. And the second E is for the equilibrium concentration, measured in mole per decimeters cubed. So as you can see, I've placed all the initial values into this table, and I have shown that the amount of P at equilibrium is 1,2 mole. Remember, we are trying to calculate the equilibrium constant, that is the Kc value for this reaction, and in order to do so, we need to know the values of all of the concentrations at equilibrium. So we're going to start off by making use of this value and that value in order to determine the change in P. We start off with 0,8 and end up with 1,2. In order to go from 0,8 to 1,2, we know that, well, particles had to be added. So we say 1,2 minus 0,8 is going to give us 0,4. In other words, 0,8 plus 0,4 gives us 1,2. Now we know that we are allowed to use stoichiometry for this section, the change in the number of mole. So since we are adding P, which is a reactant, we know that we're going to end up adding Q, and if the number of mole of the reactants is increasing, then the number of mole of the product is decreasing. So now we say the ratio of P to Q is 2 to 1. 0,4 divided by 2 gives us 0,2. So the change in Q is going to be 0,2 mole. The ratio of P to PQ is 2 to 2. In other words, that is 1 to 1. So we know that the change in PQ is going to be 0,4. Now that we have worked out the changes using stoichiometry, we can say 0,8 plus 0,2, and that gives us the equilibrium number of mole of Q2, which is 1,0. We can go on to PQ and we can say 3,2 minus 0,4, and that gives us the equilibrium number of moles of PQ to be 2,8. Now, in order to calculate concentration, we go to the table, so the table in the formula sheet, and we find on our formula sheet that concentration is equal to number of moles divided by volume. We were given the volume of the container being used right at the start of this problem. They said we are using a 2 decimeter cubed container. So what we're now going to do is we're going to take the equilibrium number of moles and we're going to divide each of them by 2. So 1,2 divided by 2, 1 divided by 2, and 2,8 divided by 2. In the end, the answers we obtain is 0,6, 0,5, and 1,4. These are the concentrations at equilibrium. So now we have enough information to work out the Kc value. Remember that when we write Kc, Kc is going to equal to the concentration of the products divided by the concentration of the reactants, where each concentration will be placed to the power of the number in front of that, well, chemical value or that chemical equation. Nope. the chemical formula of each of the compounds, right? So we know that the product in this reaction is PQ. We take the concentration of PQ. Fortunately, all of these, values, all of these compounds are in the gaseous state, right? So that means they can all be included in the Kc calculation. So we take PQ, we're going to place it to the power of 2. Where did I get that 2? From the ratios. Then we're going to divide this, number 1, we're going to divide it by the concentration of P. And this we're going to place to the power of 2, multiplied by the concentration of Q2, which we're going to place or leave to the power of 1. We can now substitute into this formula all of the values that we know. So it is 1,4 to the power of 2 divided by 0,6 to the power of 2 multiplied by 0,5, and that remains to the power of 1. When we place this into our calculators, we find out that the value of Kc is 10,89. And remember that Kc is an equilibrium constant and therefore does not have an SI unit. It is simply a constant which is left as a number. For a question like this, you're going to get, firstly, 1 mark for including in your rice table the initial number of moles that were given to you. You're then going to get 1 mark for working out the change in P, which is 0,4. You're going to be awarded the 3rd mark for determining the change in the other compounds using the mole ratio, so that is your 3rd mark. Then you're going to get a mark for determining the number of mole of Q2 and PQ at equilibrium. Then you get a mark for working out the concentrations of all of these reactants and the product. They all need to be correct. We then go to the Kc expression. We're going to get 1 mark for first writing out the Kc expression. So please do not neglect to first write out the Kc expression, remembering that solids and liquids are excluded from this expression. You're going to get 1 mark for substituting into the Kc expression and 1 mark for your final answer. This gives us a total of 8 marks for question 6.2.3. Question 6.2.4 says, how will the equilibrium constant calculated in question 6.2.3 be affected when the volume of the container is decreased at a constant temperature? Choose from increases, decreases, or remains the same. The equilibrium constant can only be affected or changed by one thing, and that is the temperature at which the reaction is taking place. If we change the temperature, then the Kc value will change. But here we are only changing the volume of the container. The temperature is kept constant. So we know that the answer to this question is remains the same. That is going to get us the 1st mark. The reason is because the equilibrium constant can only be affected by temperature. For writing this down, you will obtain 1 mark. As an alternative, you can simply say that the temperature is kept constant, and that will be a suitable reason for your answer as well. Question 6.3 is the last problem in this video, and it says more Q2 gas is now added to the reaction mixture at constant temperature. How will each of the following be affected? Choose from increases, decreases, or remains the same. 6.3.1 says the yield of PQ. Now this is a reaction that is taking place in a closed system, or this is in a sealed container, and therefore the system is closed. So we're going to be making use of Le Chatelier's principle, which says that when a disturbance is imposed on a system, the system will act to reinstate equilibrium by favoring the reaction that opposes the disturbance. So what is the disturbance? We have added more Q2. So what will the system aim to do? It will aim to reduce the amount of Q2. And how does it do so? By favoring the forward reaction, because the forward reaction will use up the Q2. So as a result, we know that more PQ is going to be produced, and therefore the yield of PQ is going to increase. We say it increases. That is going to get you 1 mark. Question 6.3.2 says the number of moles of P. When Q2 is used up, it is used up together with P. So therefore, since the number of moles of Q2 is dropping, the number of moles of P is going to drop as the forward reaction is being favored. And therefore, the answer to 6.3.2 is decreases. And that is going to get you 1 mark. This brings us to the end of question number 6, which is out of a total of 18 marks. In the next video, we will look at question number 7, which is about acids and bases.